All right, folks. Next up on stage is Mark Smith. He's going to talk to us about Python functions and all the things we don't want to know about them, but we probably should, or something like that. Anyway, it's a long talk. He has a lot to say. I'm going to get off the stage.
Thanks, Marcus.
Give him a round of applause.
Hi, everybody. So this talk I put together because I feel people tend to learn functions quite early on as they're learning to program, and especially when they're learning to program in Python. And then they quickly move on to other topics. It's like, hey, we've covered functions. They're reusable code. Let's move on. And so I think people often miss the details of how functions work, how function definitions and function calls work. And it's all picked up a bit ad hoc. And occasionally people can have blind spots for quite some time, which come back to bite you later on. So this talk is going to start with the very basics that you almost certainly know, and then gradually move into some of the more advanced, more esoteric stuff, some of the stuff you may not want to take advantage of at work, because some other people you work with may not really understand what that code is doing. The first time I gave this talk, I had a 45-minute slot, and I ran over, and I've attempted to squeeze it into this 30-minute slot, so we'll see how I go. So I'm going to go really fast, hopefully not too fast. But before I do start, I'm going to have to talk about myself briefly. I am GD2K, pretty much everywhere online. My real name is Mark Smith. I'm a developer advocate for Nexmo. If you haven't heard of Nexmo, we provide web-based APIs that allow web developers to write code that sends SMS messages, makes phone calls, does video streaming, or communicates via different instant messaging platforms like Facebook Messenger, Viber, WhatsApp, WeChat. That's enough about me and Nexmo. Let's look at a simple function. So here's a function. It's about as simple as you can make it. And here I've added a couple of lines to actually call that function. So what's worth noting is this line, the definition line, is executed once, probably, in your program, when the module is loaded. Whereas this line, the call to the print function, is executed every time the function is called. So in this page, this very short page of code, the definition line is executed once, and the print line is executed twice. Functions are variables. They don't really look like variable definitions in the rest of Python because there's no equal sign there, but this first line, this block, is defining a variable called sayHello of a type function. And the variable is called sayHello. Here, I'm just assigning the value of sayHello, which is the function, to a new variable called hello. And in here, I'm calling hello as if that was the name of the function definition, and it does exactly the same thing as if we just called sayHello directly. A side effect of this is that you can put functions into lists, dictionaries, or anywhere else you would like to store a value, which is kind of useful, and other languages don't necessarily support that behavior. But a function like that last one, which doesn't take any parameters and does exactly the same thing each time it's called, assuming it's not reacting to outside state, isn't that useful. So we often define functions that take parameters. Parameters are just variables that can be provided with values or arguments when called, and then those values can be accessed inside the function. They're how you hand data to a function when it's called. And here's what it can look like when you call the function with some arguments. Now, just a short diversion to make something really explicit here. Definitions and calls to functions look very similar. And so people, including me, mix up the terminology, and I'm going to try not to in this talk. So in this definition, these things are parameters. So they're placeholders for values that will be passed into the function. Whereas in the function call, these things are arguments. So they are actually values that are being passed into the function. So they can be literals like they are here, but they could also be variables whose values are being passed in. I'm going to attempt to be consistent through the rest of this talk, but I almost certainly won't manage it. So even with a simple definition like this, we can now call this function in a number of different ways. Here we are calling it with positional arguments. So the first argument is assigned to the first parameter, and the second argument is provided to the second parameter. Here we're calling it with named arguments. So it's slightly different. It's very readable. It's a little bit more verbose. So we're passing both parameters in by name. And this has the side effect that we don't need to pass, the order is no longer important because we're explicitly naming the arguments that we're passing in. So we can pass them in reverse order, which may or may not be confusing depending on the function definition that you're calling. You can combine these two approaches. So you can combine a positional argument in this case and a named argument at the same time. The positional arguments are bound first. And this can cause problems. So in this function definition, the first argument is bound to the first parameter called recipient. And then it's now finished mapping all the positional arguments, so it's now going to map the named arguments, and the named argument is recipient. And recipient has already been bound, so you get this error explaining that you've provided multiple values for one argument. It doesn't know which one to pick. So Python helpfully raises an error in this case. Also, something to point out while we're talking about the basics of function definitions is that you must provide values for every parameter. Oh, excuse me, I wiggled the cable. Is it going to come back up? Have we got anything? I've got, I suppose, right. There we go. Sorry about that. So we must provide, unless it provides a default argument, which we'll get into in a moment, you must provide parameters. You must provide arguments for each of the parameters. So in this case, we're calling this function that's been defined to take 2 arguments and not providing it with any arguments, so we get an error. This isn't true of some other languages, the most notable which is JavaScript. So, but you can provide default arguments. So you can make this parameter optional. They're defined in the definition, not in the call. So it looks like the named arguments that we were just showing, like how to pass named arguments into a function. But in this case, it's in the definition line, not the call. So all these calls are now valid. So in the first call, we're just not providing a value. In the second call, we are actually providing value by position. This is the third argument, so it's assigned to the third parameter. And in the third case, we're just providing it explicitly by name. So, another thing to point out is that when you have parameters with default arguments, they must be last in the parameter list, or they must be after all of the non-optional parameters. So this default parameter is defined before this non-default parameter, and so it doesn't work. You get this error. And while we're talking about providing default arguments to parameters, I want to run you through some of the problems you can have with mutable arguments. This catches some really intermediate Python developers who are then surprised because they thought they understood how this works, and they find out they didn't. So in this case, this is a different function definition now, and recipients, instead of being an immutable string, is now a mutable list. And the implementation itself, the 3 lines of code there, is it just loops through the recipient, sending each one an SMS. So, I mean, it's technically fine. You can see from this first function call here that it's doing, in fact, both of these function calls, it's doing kind of what you'd expect. But then our requirements change. So a couple of months later, somebody says, oh, but every time we send all these SMS messages out, we also need to send an SMS to the debugging phone or the logging phone, something like that. So we have this 666 phone number, genuinely picked at random. And we're just appending that value to the list. So each time this is called, it's just appending that value before then looping through all the values and sending the SMS messages. And you can see from this first function call that it's actually working fine. But unfortunately, when you call it a second time, it then sends to the logging phone twice. You can see the 666 number. It comes up in the print messages twice. Now, why is that? And it comes back to the second slide when I mentioned that this define line is executed once. So this list is created here. And here, it appends to the list. But as I said before, the definition line is executed once in your program. So that list only exists once in your entire program. And you're modifying it each time you call this block of code. So the fix is not too difficult, so let's fix it. So the fix is to replace that argument with an immutable value. None is a good immutable value. People don't have to go and look it up. It's kind of, and you can put it in the documentation. If you provide none, then this list will be used. And then we check to see whether it's none, and then if it is none, we then assign to that value with the default value that we really wanted all along. And everything else is the same in this function definition. So we call it twice, and now we get the behavior that we wanted. It's sending it to the default number, and it's sending it to our logging phone each time. But there's actually still one problem here. I have to admit, I've implemented this so many times and still got it slightly wrong. So let's look at another way of calling this function that we've just defined. So here, instead of using the default value, we're actually passing in a variable that we've created. So we've created this recipients variable in our own code. We're calling the function, just passing in recipients. The problem is recipients now still exists after the function has been called, and it's been modified. So we didn't assign a value to it, we just appended to it. So each time this is called, recipients will get a little bit longer, and that's probably not expected behavior. The users don't expect you to change variables in their scope when you call a function with that parameter. So let's just fix that. And the fix, again, it's another line of code, but it's still relatively simple, is to, instead of modifying the variable that's passed in, we create a new variable, in this case called all recipients, create that with the values that we want in it, and then loop through that. So in this case, all recipients is local to that function. It stops existing after the function exists, and so we're not modifying anything that exists in another scope or the next time the function's called. So it's a little bit fiddly, but once you understand what's going on there, it's not too hard to understand, I hope. Let's talk about variadic parameters. I only came across this word a short while ago. I don't have a degree in computer science, so I missed some of this stuff. I have my own holes in my knowledge. So variadic parameters in Python, often called star args, allow you to provide an arbitrary number of positional arguments. So you define one variadic parameter, in this case star args. By convention, it is called args. And by putting this asterisk in front of the parameter name, it just means that we can now provide as many positional parameters as we want. They will all be added to a tuple, and then the tuple will be passed into the function, in this case, as given the name, whatever name you gave that argument. So in this case, it's called args. So we can call this with as many parameters as we like, and each time args in this case, args is called with one value, two values, or three values. What it isn't doing is creating a new parameter. So args is not a parameter. You can't explicitly pass in a tuple. There is a way to get around this. If you want to, we'll be covering that in a moment. There is also a version of this for keyword arguments. So if you want to provide an unlimited number of keyword arguments to a function, named arguments, sorry. Unfortunately, named arguments are often called keyword arguments, but they have nothing to do with Python language keywords. So it's a really bad name. But they are, in this case, the convention is to call them KW args, which is also difficult to say out loud. But anyway, I call them named arguments. So in this case, we've created a dictionary called KW args, and any named arguments that are passed in will just be added to that dictionary, and then the function will be called with that dictionary value. Here is I apologize for skipping around a lot. We are trying to get through a lot of stuff very quickly. Here is a function with too many arguments. PyCharm or PyLint will both complain about this function because there's just too much data going in there. But while we have this function that sends an SMS, let's use it to send an SMS from our phone to a friend's phone with containing a restaurant phone number. And it looks like that. And obviously, it's really difficult to work out which number's which, like which one's my number, which one's the restaurant number, which one's my friend's number. They're all made-up numbers. Don't dial those. You can get around this by calling it with named arguments. So this is obviously a lot more explicit. It's a lot easier to understand what each of those numbers are. Highly recommend you use this style for this if you have a function that takes this many arguments. The thing is, it's complaining about the definition because the definition's too complex. But it's not really too complex if it's always called in this way. And then one of the nice features in Python 3 is that you can enforce this convention for your function. You can force your users to use named values. So here we have, this is how you do it. You provide a single asterisk as a parameter. It's not really a parameter. It's just kind of a marker in the list of parameters. And what this means is after that asterisk, each of those parameters must be provided by name. So yeah, if you try to provide them as a positional argument, you will get an error. And this will also has the side effect of stopping PyCharm or PyLint from complaining that your function takes too many arguments. You don't have to use it at the start. You can use it in the middle. So in this case, this is a kind of mixed mode function where you can, if you want to, provide the first 3 arguments as positional arguments, and then the rest need to be provided by name. This is really, you can see that asterisk is kind of overloaded now. It's being used for a lot of things. What this is really doing, so this is really kind of a variadic argument, but with no actual argument. If you want variadic arguments as well, if you want to be able to provide more and more positional arguments, but still enforce this style of calling, you can do it like this. So we can still provide an actual name, and this will then take as many positional arguments as you like. But you still must provide, for example, message type as by name. Right, so this is the opposite. So here we've got the same kind of notation, the asterisk args and the asterisk kw args, but this is in the function call, not the definition. And this does the opposite thing. So this unpacks from a tuple into positional arguments, and it unpacks from a dictionary into named arguments. So it just means if you want to call a function and you're not quite sure what arguments you're going to have available at the time, let's say you're going to be receiving network requests with sort of data that makes up your function call, as long as you can provide this tuple of positional arguments and this dictionary of keyword arguments, you can still call the function this way. So that can be kind of handy. Talking about return values briefly, by default, Python functions return none, unless you use so this doesn't work, this always returns none, because we're not using the return statement. So you need to use a return statement if you want to return a value. This is obvious to people who always work in Python, but it's not obvious to people like Ruby and perhaps Rust programmers. So I'm going to talk about scope now, because you kind of have to. When I started Python, there were only 3 scopes. There was function, module, and built-in scope. Module, I call it module scope, but generally it's referred to as global scope, but it's not really. It's within a single module. I'm going to alternate between those two terms. I apologize. So we can access global variables inside a function. So here I've defined use HTTPS in module scope, and then I can still access it in my function, and that works fine. I can mutate it. So if it's a mutable value, I can kind of modify that data structure if I want to. But what I can't do, unless I do something special, is assign to it. So you've all used equals before, and if you use equals inside a function, it defines a new variable inside that function scope, and that's exactly what's happening here. So use HTTPS is defined inside that function. After the function call is over, use HTTPS doesn't exist inside that function, so it sets it and then lets it go. And this means that if you call set HTTPS with a value of false, use HTTPS is still true because you haven't modified that global value at all. The way you get around this is to use, I'm really rushing through this. The way that you get around this is to use the global statement at the start of your function definition. This just says, when I refer to use HTTPS, you need to use the global definition rather than a version inside the function. So global, the statement allows you to get from a function to module scope. We can define functions inside functions. They're called the enclosing function is called a closure. And you can see inside this inner function that I can access URL from the outer function, and then I can return get. Now, get hasn't been called at this point when we call get later, but it has returned you a new function that has access to that URL when it's called. So later on, we can call the getter, which will call the inner function with the value that was passed in 2 lines ago. The problem comes, so this all works. The problem is that now we have functions inside functions. And it works as long as you're accessing a variable. But if you want to modify a variable, so in this case we've got value in the outer scope, this does exactly what the global code, the code that was modifying the global variable does. It looks like this, right, if we take out the outer function definition. So we've got the same problem. Value in that inner function only belongs to that inner function. And global won't help us because that value variable on the outside isn't global. It's defined in the outer function. So what we need here is non-local. Non-local is very similar. It's equivalent to global, but it gives you access to the outer function scope. So just to recap what those are doing, global allows you to get from an outer function to module scope. An inner, it gets you from an inner function to global scope, but if you want to get from an inner function to an outer function, you use non-local. Methods look a bit like functions, but they all take self. But when you call them, they don't take self. They're called on the instance, that red arrow there, but somehow that becomes the first argument into the function. So we need to understand this more. We need to look at what these are. So to look at send SMS on the class where it's defined, we have a function, right? We understand functions. We've been talking about them for 20 minutes. But if we look at it through the instance, my client, you get something called a bound method. So why is this different? There's nothing on that instance. It's actually accessing it via the class. And to understand this, you need to understand the descriptor protocol. People do whole talks on the descriptor protocol, so I'm going to run through it, like really skim over it. But I'd really recommend Googling it, watching talks on it, reading the documentation. It's a fundamental thing about how the Python data model works. It's really interesting. But what it basically states, some of it, is that when you access a class attribute via an instance, if that attribute defines a dunder-get method, so a magic method, that will be called. Instead, it won't just pass back the attribute, it will call it first and return you the value that was calculated by calling that method. So here's a bad example. So we've got a class with a URL attribute, which is a string, and then we create an instance of it, also called client. Should have called it my client or something. Now here we can access the URL on the instance. And what the Descriptor Protocol says is, if that value implements dunder-get, then actually that first line of code becomes that third line of code. So it calls dunder-get with the instance and returns you the result. And this is actually the way that methods work in Python. So what happens is you've got this client class with a send-SMS attribute, and the send-SMS attribute is an instance of something. It's a function in this case, and that implements dunder-get. It has a dunder-get method on it. And so what happens is when you try and access that through my client, it creates a new method object. So it's slightly more complicated than this, but this is the summary of it. It creates a method object with the instance that it was passed, because it calls dunder-get with the instance, and then it hands you back that method object that wraps up both the function and the instance. So this is why you don't need to pass self in when you call a method, because it's already available to the method. The method is unique to that instance, conceptually. So this is what actually happens. So when you call send SMS on the instance, it's actually calling dunder-get on the class attribute and then calling the thing that's returned from that. So that's that bound method that's actually executing. And so this gets us into how can you have things that are callable that aren't actually functions, because dunder-get isn't attribute or the thing you're returning, this method, is a callable, and it's not really a function. So this is how you define an instance that is callable. You just add a dunder call method to it, and then once you've got an instance of it, you can call it as if it was a function over and over again, and it can store state on self or access state from self as much as it likes. 2 minutes, right. So this is kind of cool. You can use closures for this as well, for storing state between function calls. But if closures are still kind of confusing to you, then instances, if you're more of an OO thinker, then classes can be a sort of more readable way to do this kind of thing. If you want to find out if something's callable, you can use the callable built-in and pass in the value, and it will tell you whether it's a callable, and that doesn't matter, whether it's a callable instance or a function or a method or anything else. So this is some of the more advanced stuff. I'm going to really skim through here. I think I can do each of these in 30 seconds. So there's an inspect module. It comes with Python. It's really cool. It will give you a signature object that represents the parameters and return values of a function, and then you can ask it, like, what types are expected if people are using type hints. You can also use it to unpack tuple and dict in the same way as arguments would be if they were passed to the function. So that could be really interesting for dynamically creating sort of proxies for network calls and things like that, if you know the signature of the function at the other end. So skimming through all of those. You could also use it to enforce type hints at runtime, which this enforce library does. That's an extremely non-Pythonic thing to do, and I don't recommend it, but it's kind of fun. You can also access the dunder code attribute of a function, which gives you the bytecode that defines how that function works, that Python generated for you. It's writable, so you can look at the bytecode, manipulate it, and write it back again. And my friend Sebastian has written a library, oh, excuse the flames. He's written a library called Python goto, which does exactly this. With a decorator that you put on a function, it essentially disassembles it, reassembles it, and allows you to use a goto keyword inside the function. It's not actually a keyword. It's quite clever the way it's done. So in summary, functions are probably more complex than you thought they were. The slides and code for this talk are all up online. Hopefully it all works. Thank you for listening.
Thank you, Mark. This was hilarious.
Thank you.
There is coffee break now, I believe, if I'm not completely wrong with the schedule here. See you later in this room or in another one.
Oh.